All right, now that that's out of the way, I'd like to welcome you all today to our APMM Model Maker Meetup session. Our guest today, our presenter, is David Brutscher. He is a degreed engineer with half of his career dedicated to designing saw blades and other edged power tool accessories. He's worked for Vermont American, Robert Bosch, Black & Decker, DeWalt, and he is currently with Harbor Freight Tool. He holds 25 US patents related to power tool accessories and is an avid woodworker in his own right. So without further ado, I will hand things over to David and he can take it from here. Welcome.
Thank you, Michael. Today we're going to talk a little bit about circular saw blade, kind of a circular saw blade 101. I don't know if anybody remembers back to their college days, but 100 level classes are really sort of for your freshmen. Then you can step into 2, 3, or 400. So I'm going to try to keep it mostly pretty basic today for you guys, give you guys some pointers to, what you should be looking for, in the circular saw blade, talk a little bit about many of the design features that most manufacturers highlight in their products. Having worked for several of those guys, we've talked through that, and then sort of take you through some details around the design features you might want to be looking at, and then on into talking a little bit about the type of blade that you should be looking at for different types of materials, and then also a little bit of a quick selection guide for blades and carbides. So without further ado, let's go ahead and get started. So, really, whenever you talk about any kind of cutting tool, and of course the session's on circular saw blades today specifically, there is an anatomy to the cutting product that you need to be aware of, and there's a vernacular and or definitions around the key features of the product for it, and how it allows that product to cut the particular material you're looking at. And so, for circular saw blades, there's really 7 to 8 key features that most all saw blades have on them, and most manufacturers highlight in their advertising material when they're talking about blades. First key one is just the plate thickness, which is, allows the, and this really conversation, just to back up, is really talking more about circular saw blades. Of course, you may have noticed my first picture there, that could have been just a steel tooth saw blade, but in modern times, pretty much all blades that you're going to see that you really want to use are carbide tipped. So, the first thing is the plate thickness, which allows the carbide to be brazed onto the blade. And then the second thing is the actual kerf or width of the carbide that you're cutting. And always you're going to have the kerf wider than the plate. The tooth angle, tooth or hook angle, which is the angle of the tooth relative to the center bore of the blade.
Hey, David, could you interrupt for a moment?
Dave, you're not getting it. None of your slides are up. We're seeing you, but not the slides.
Well, let me open it up fully. I was told I was sharing, but let me just make sure that I've got this shared, and we'll go from there.
There we go. Perfect.
All right. Can you guys see that?
Yes.
Okay. Sorry about that. I thought I was sharing already. Should ask that question. So anyways, just again, on the blade anatomy we were talking about, hook angle, which we talked about just a minute ago, top clearance angle, really, this is the angle that you're looking at from top of the tooth down to the bottom of the tooth. From the front of the tooth to the back of the tooth to the very top. Then we have your side angle clearance, which is the, actually there's 2 forms of this. There's a tangential clearance, which is the clearance of the tooth from front to back, and then the radial clearance, which is the clearance of the tooth from the top of the tooth to the bottom. And again, this is when you're looking at the front of the tooth, front face of the tooth. The next is just your, overall cutting diameter, which is really tied primarily to the power tool that you're using. And that can be from, 3 3/8 all the way up to almost as big as you want to get. But probably 7 1/4, 10 or 12-inch diameters are really the key ones for most shops you're dealing with. And then we talked a little bit about the radial clearance there already. Really, the reason that all carbide has the radial and tangential clearances is that, you have to have only the cutting edge of the tooth form actually doing the cutting, right? There's not many manufacturers that will talk specifically about these angles. These are somewhat pretty heavily guarded secrets because they do impact either the performance of the blade in terms of some of the key features, performance features like tear out or surface finish. But then if they're too low, you don't have enough clearance, and that causes the blade to burn significantly or things like that. So just whenever you're looking at a circular saw blade, you look at it closely, you can see that it's sort of a trapezoidal shaped tooth form that's there. All blade manufacturers really vary these key features to get blades that will cut either faster or slower or perform different tasks in different types of materials. And then along with that, of course, there's many grades of carbide that exist out there, and they're really tailored for cutting wood, wood composites, plastics, ferrous, and non-ferrous metals. And that research is ongoing, even so much. I was out of sort of this particular industry for about 3.5 years, and I'm amazed at the number of additional new grades that the big manufacturers of carbide and Cermet have come up with even in those last 3 or 4 years. Okay. See if I can get my okay. Sorry, fellas, a little bit of there you go. Sort of a little bit of a lag for me on this end. Okay, so just talking a little bit about the tooth forms for cutting wood and wood composites. That's obviously a very big area. A lot of people use these kinds of materials for cutting, and obviously I use it quite significantly in the cabinetry making that I have. But really, there's 4 general types of carbide or shapes, tooth form shapes that are out there for cutting wood and wood composites. First one is a flat top ground, and really it's the oldest form, tooth form that's out there. Way back in the day when carbide was first put on blades, really no one thought about, hey, what's optimal or not. But it's a great blade for just grooving cuts or rip cuts if you have those to do in your shop, especially grooving cuts, in the 1/8 inch wide range or so. Gives a flat bottom of the tooth, in whatever you're cutting. So it's non-through cuts, things of that nature. Next is alternate top bevel. These are really best for cross cutting and trimming wood and plywood. And probably the most diverse blade form that's out there in terms of the number of manufacturers that have the blades. Different hook angle combinations with different ATB angles, all of that sort of stuff. So that's a significant number of blades that exist for that tooth form. Then the next is really a combination, and this blade is a combination of a left and right ATB followed by a flat top tooth. Usually it's a 5-tooth combination, so you have a left ATB, right ATB, left ATB, right ATB, then followed by a raker or flat top tooth. This is the kind of blade that I actually use on my table saw because it's a very it's a very good blade for ripping plywood or hardwoods, but it also can do cross cutting very well as well. 10-inch 50-tooth blade on my particular saw that I have, which is a 10-inch table saw. So then the last is a triple chip ground TCG. These are really good tooth forms for cutting either chip prone woods or composites, melamine, low pressure laminates, things of that nature, and is one that usually is a hook angle of either zero, neutral, or some negative hook angle. But if you're encountering or using melamine or any products, panel products like that, it's a good tooth form to use for those kinds of applications. And then really, tooth forms for cutting plastics, non-ferrous, and ferrous metals is really the newest research areas up until about 15 years ago. Cutting metals was a category that was just industrial-based saws only, right? Circular saw blades. But now there are a number of different manufacturers that produce a whole line of different metal cutting circular saw blades for all sorts of applications. And it continues to be, one that there's additional research in that. Really, I mentioned the triple chip ground tooth already. But it actually is a very good blade for non-ferrous metals, again, aluminum, brass, materials along those lines. And that's really primarily because you're really cutting a material that could be either thin wall or it's very soft. And that, again, that negative hook that you generally see with triple chip ground blade, 0 up to about -5 degrees, creates more of a planing cut, and that keeps the blade from actually grabbing the workpiece. So whenever you're doing aluminum or cutting aluminum, things of that nature, brass, soft metals, that's a really good blade. Then moving on to carbon steels, modified TCG blades are really out there in this realm, and they're really good for primarily cutting carbon steels. Different manufacturers have different tooth forms of these. They might have a long flat on one side, a short flat on the other, or more of a centered, two centered flats of that nature. But really, if you're out there looking for metal cutting modified TCG blade, it is really the best route to go for carbon steel and for stainless steels. And really, the difference there, as you'll see in the selection guide, is really just the hook angle. Actually, carbon steels, a lot of people think, well, stainless steels is a material that is much harder to cut. But really, stainless steels are more gummy and are actually softer than the carbon steels. So when you're looking at or selecting a blade and you're looking at carbon steel, you're really looking at again, 0 to -5 degree hook, really in that range of blade, more of a planing cut. But if you're looking at stainless steel, it's best to actually have a blade that is slightly positive, generally 0 to about 3 degrees of hook, maybe up to about 5. But that allows the stainless steel to actually form a chip more efficiently and to come off of the front face of the carbide, so it makes it not wear so quickly. And then really the last is a modified ATB. And this is really the best sort of tooth form for cutting plastics and plastic composites. So that could be solid plastics, or it could be fiber reinforced plastics, things of that nature. Okay. Any questions so far?
I actually did have one. So as far as cutting steel on a saw like that, I mean, are we talking about a special type of saw with coolant and whatnot, or are we just throwing this on a table saw out in the shop?
No, that's a very good point. Thanks, Mike. Generally, when you're looking at metal cutting saws, they are purpose-made saws, and they generally are much lower RPM than what you would find on the wood cutting saw of the same diameter. So, for instance, if you're looking at a 7 1/4 inch blade, Generally, if you're looking for one that's just a circular saw blade for cutting wood, you might be 5,500, 6,000 RPM at modern saws. And really, for a wood cutting saw that same diameter, you're probably talking 3,800 RPM. So it is a different saw. They are designed, a lot of them are designed to catch the chips, and that continues on up through the line. So a 10-inch blade or 10-inch miter saw for cutting metal is going to be much slower. I know the 14-inch, for instance, is in the 12 to 1,400 RPM range. So yes, it is quite a bit slower than your same equivalent wood cutting saw. Power tool, that is.
All right. Thank you.
Yep. Okay. All right. Moving on. And then just a few key other design features to remember. Really, whenever you're trying to select a blade, I think one of the first things to remember is that the number of teeth really impacts both the cut speed and the cut quality, right? We get questions all the time, or I get questions all the time. Well, I was using this blade and it was a 40-tooth blade and it started chipping out on me. I was using this really expensive plywood. And my answer to most people is really what you need to understand is that the number of teeth in a certain diameter is teeth per inch. And that really impacts the chip load that you have there. So it's important to really recognize that the greater number of teeth you have, the finer the blade is. So the finer the cut's going to be. But at the same time, you're going to give up speed because really what you have going on there is you have more teeth in the material you're cutting at any moment in time. And so the blade is going to be, there's trade-offs there between. So you really need to kind of say, hey, what's the material I'm cutting and how fine of a cutter am I looking at? But you are going to kind of, give up, there's going to be a trade-off there. Fillet size is something that some manufacturers talk about, but it does impact a blade's ability to remove the chips from the cut site. And that, that's just important. Again, if you're doing rip cuts and you're ripping pretty fast, to be able to actually get the chips away from the cut site, because that keeps the blade cutting efficiently. And, that can be said for cross-cutting blades as well. Positive hook angles cut more aggressively, and that's really better for wood cutting. Generally, when we talk about wood cutting blades, above 10 degrees all the way up to about 25 degrees is sort of the range that makes the most sense for wood cutting. And then for metal cutting, neutral or negative hook angles are, really best for most metals, except and plastics, that is. And again, stainless steel is sort of a different category versus your carbon steels with slightly positive hook angles. But generally, that's what you want to be looking for if you're cutting metals. One thing I would say about aluminum specifically is that aluminum is its own class of non-ferrous metal, same as brass. There was the question about whether you could run a aluminum blade on a regular circular saw. This is one that I had a huge debate with for a number of years with one of my employers. And what we know is that aluminum, because it is softer, it really benefits from the much higher tip speed, much lower chip load of a wood cutting saw versus the metal cutting saw. So anybody that's looking at cutting aluminum, I believe it's perfectly fine to put those on a table saw or a miter saw that's designed for cutting wood. Some of the manufacturers might not like the fact that you might foul your commutator brushes, things of that nature, but from a finish standpoint and the application, perfectly acceptable. And then moving down, thinner kerf blades, they're going to cut faster because they're just not removing as much material as doing as much work. But they may introduce poor cut quality. Generally speaking, most woodworking saw blades are going to have around a 1/8 kerf, so a kerf width 125.125 inches. And that's generally what you're going to see from all the major manufacturers. But blades that are meant for miter saws, 10 or 12-inch miter saws, can be thinner kerf. Again, because they have less power, table saw generally is going to be 3 horsepower or 5 horsepower if it's a stationary saw versus 1.5 to 2.5 for a miter saw. So just keep that in mind. When you're using a thinner kerf blade. And then one thing that I would note is that you really need to be careful with high positive hook angles when using miter saws, especially your slide miter saws. I know that there's quite a bit of confusion out there, or people that will get a blade that's 15-degree hook angle that's maybe for wood cutting or something of that nature, but you have to be very careful about not having the workpiece move or it grabbing the blade grabbing the tooth or the workpiece and pulling that either into the saw or some other catastrophic event. This is something that that I've spent a lot of my career working on in terms of where we think that angle should be, and I would always suggest for slide miter saws, lower is better. There are a number of blades out there that are 5-degree hook angle or 7 or 8, somewhere less than 10 degrees that I think are really the blades that you want to be looking for in that particular application. Okay. Just a quick chart on the blade selection guide, just to kind of give you guys some details again about it. The large X really represents what I would refer to as the most favored blade to use for the applications you're looking at, and the particular tooth form. So really the flat top ground blade, it's really best in wood and ripping applications and or grooving applications. You can also use it for melamine and laminates, but again, because they are way more chip out prone, I don't normally suggest those. In the ATB, really, I think wood and melamine and laminates is really the best for that product. And if you're looking at a hook angle, generally 7 to about 25 degrees is kind of where you want to be. Again, it depends on some applications, and then the ATB angle of somewhere between 10 and 30 degrees. Most of the major manufacturers sort of fall into that category. High ATB angles, there's a number of companies that have that, which is great for scoring and low chip out, but it does impact the finish, surface finish of the cut you're making, just because of resultant angles, cutting angles, which is the force that's caused by the tooth actually cutting through the material, being out of plane with the actual plate of the blade. And the higher that angle, the more out of plane you are. Then next, ATBR combination blade. Again, they're good in wood, melamine, and laminates, and they also work very well in plastics. But again, I think the key is really in hardwoods. Really with a hook angle, again, somewhere between 5 and 25 degrees. Can be a little lower there because of the raker tooth involved. And then the ATB again from about 10 to 30 degrees, but the ATB angle tends to be again a little lower because of the raker tooth. That raker tooth actually centers the blade as it's making a cut. So there's a number of manufacturers out there that have introduced within the last few years some 7.25-inch blades that have a 3-tooth combination, left ATB, right, and then a raker tooth in their lineups. Then moving on to TCGs, really melamine and laminates are really 2 suggestions there, and then the non-ferrous metals, aluminum specifically, and with the understanding that really 0 to -5 degree hook angle. Can everyone hear me?
Yes.
Okay, I've just got I've got a connecting thing that popped up, so I'm hoping that we'll get through vagaries of Zoom meetings. But then moving on to the TCG.
We did lose your sharing though, and you're muted at the moment.
Hey, Michael, I think as host, you can unmute him.
Yeah, I just clicked ask to unmute. I'm also curious if it might be possible for him to turn off his personal video without turning off the share screen. I'm not sure if that's possible in Zoom or not. I'm wondering if it's eating up the bandwidth on his video or something.
Is he frozen too?
Yeah, his video kind of appeared to be. I noticed it seemed to be lagging more and more there for a few minutes prior to that happening, so hopefully it's just one of those hiccups. Well, we'll give him a minute to hop back in, or maybe if he can hear us, he can disconnect and reconnect. Try that out.
Yeah, it looks like he just dropped off, so hopefully he'll get back on.
Maybe he needs a new flux capacitor for his video cam.
Yeah, definitely a lot of factors to a saw blade I'd never considered.
Does everybody understand? Oh, there he is. Okay.
Welcome back.
You hear us, Dave?
Dave, can you hear us at this point?
Hey, we can't hear you. We see you, but we don't. Okay. Yeah, just a reconnect would be great. Okay. Yeah, he's reconnected.
Okay.
Does everybody understand hook angle that he was talking about? Anybody need that explained? It is one of the crucial things for the different blades.
Well, if you care to elaborate, we're here anyway, so why not?
Yeah, if you go
I'm
from
all
the,
ears.
okay, if you go from the center of the arbor and go straight out, I'm not sure, I'm not an engineer, but I think almost like a tangent or whatever, straight from the center of the arbor straight up, that's 0. So if my rotation is this direction, then positive would be this way, negative would be this way off of that 0. So it's the attack angle is what I used to call it, of the tooth against the work stock. If it's leaning towards it, it's positive. If it's leaning back away from it, it's negative. Okay.
And I might have missed in there, what was the advantage to the negative angle?
Well, depending upon the material you're using, usually in plastics, the slightly negative, as he was saying in Checky's charts for the amounts, but a negative rake or a negative attack angle tends to tear the material less and tends to make for a smoother cut. It also allows for the chips to clear. And that's another thing, I don't know if he'll touch on it or not, but we learned that the gullet has to be clear of the stock. In other words, when I dial that saw up into my work here, I want that gullet to be totally clear of the piece, not just the teeth, but the gullet. And the gullet then will have a better chance of eliminating what has been cut and being clean the next time it comes around. Okay. You can ask him what his opinion is nowadays, but when I retired 10, 15 years ago, we always set the gullet clear because it needs to be clear. It's what it's designed for, is to throw that chip out and get rid of it, whatever the removed stock is.
That's useful information. Thanks for the extra explanation there.
Yeah, some people use, I mean, I didn't know. I had a cabinet shop for 20 years before I went to work for Woodland Ceilings, and I was setting my blades so the teeth were just above the work stock, and they said, no, set it up. So you gotta have your gutter clear. You live and
Especially
learn.
if you're cutting ABS sheet.
Yeah, you really, yeah. And I cut aluminum 1/4 inch on my big 3,500 RPM table saw all the time. But I have a really high tooth and I have a negative, see on the aluminum, I have a slight positive. If I'm cutting anything else, I have a slightly negative. The other thing we used to do, which is totally weird and crazy, is turn the blade around backwards. Don't recommend it. You sure want face protection on, but you can actually cut some very thin stock with the blade running backwards. Just being wild and crazy.
Ask me how I know.
Yeah, you tried it, huh? Can't hear you.
Muted.
Jill, you're muted somehow.
There we go. I had a bandsaw blade manufacturer tell me that when I was trying to precise cut carbon fiber rod. It was like 80 thousandths carbon fiber rod. He said, yeah, just turn the blade inside out and run it backwards on the bandsaw.
Mhm.
I thought it was kind of crazy, but
It worked.
it worked.
Yeah. Yeah. Nutsy fruits are, but they were outside the box thinking.
Well, I was feeling a little vindicated when he mentioned it's okay to do aluminum on your wood saw, because we've been doing that in the shop for years. We have metal cutting saws specifically for things like steel and whatnot, but with aluminum, yeah, we frequently would do that and never seem to have any problems. So
As long as it's a fairly low positive angle, it'll do pretty well.
anyone else find themselves cutting any odd materials like metal they probably shouldn't be on their saws, late at night when, didn't have any other options?
Just don't do it without face and eye protection. And I mean
And
full
glove.
face.
And gloves.
Yeah, well, be careful of that.
And if a saw stop, turn it off. The electronics.
Mhm. They used to get on us about wearing anything that hung down. We couldn't wear our badges. We couldn't wear anything like that around the table saws, anything that would get caught. But
It's the
then I
most
worked,
dangerous tool in the shop.
well, I think the bandsaw is, but we could debate that. But when I went to work at Atlanta for Atlanta Models and Exhibits, I walked in, the first time I'd ever seen model makers doing this. They were on full-fledged table saws, Powermatics, and they were using their X-Actos with an X-Acto blade in it to push the thin stock through the blade. That I did
I
not
can see that.
I did not do that.
I wouldn't
Make
do
a
it, but I
push
can
stick.
see it.
Make a push stick, please, But yeah, it was common practice. They'd shove their thin work stock through with an X-Acto as the push mechanism. Could not believe it. Yeah. Can you imagine if a blade ever caught one of those knives? It'd be like a missile right through you.
No, thank you.
Nice sharp blade just to make sure that it goes all the way,
Boil it first.
Yeah, right in the middle of a model shop. You gotta be kidding me.
What that sterility factor?
Yeah, right. Kind of shot out the window. Even in a clean shop like Garmin, I don't think you'd want to pick something up off the floor and eat it.
We
No
actually
offense, no offense, Michael.
Right. We were talking to some high school kids in an engineering program yesterday, as a few of us were talking to them about X-Acto knives and X-Acto knife safety and whatnot. And I was about to jump in there when Terry said the table saw was the most dangerous tool in the shop. I don't know. I almost have to say the X-Acto might be right up there with it, just in terms of sheer injuries caused in a year across the country. I suppose the table saw is probably going to be more catastrophic when you strike, but the amount of bloodshed in general all over the world, I'd have to think X-Acto blades would take the cake.
I'll
Yeah.
change that to most dangerous power tool in the shop.
There you go.
They were debating that in fine woodworking one year. And I really thought one of the cabinet makers there had a good point. And that is that the table saw is going so fast that yes, it may cut you, but you can pull back away from it. But a bandsaw is almost 100% a positive rake. In other words, it's attacking. And if you've ever put stock there, especially a dowel, try that and it'll be just like your finger. It will literally suck that dowel in, and that positive rake angle makes it, in their opinion, and I tend to agree with him because I've got a couple of nicks, but it's hard to pull away from that bandsaw. Once it grabs you, it's got you, and it's dangerous.
The problem with the table saw, though, is you can pull your hand away, but the thing is, the speed between your brain and your muscles pulling that away, depending, I mean, you have no idea what's going on. Did you just get back from lunch? Did you have a beer over lunch? Or are you tired? You didn't sleep enough? So many factors. And, you know, I eliminated the whole thing by buying a saw stop.
Yeah.
It's never fired off, but.
I went to work in Memphis, and those guys were a fully fledged stagehand union shop, and they built the sets for Miss USA. And at lunch, the first day I was there, we went back to the lunch area, which they had taken the huge crates that they used for their sets, and had made a tunnel that you could literally, I mean, his crates were 8 feet tall. You could walk back in this thing. It was amazing. You got all the way back to the railroad door. They threw the door up beside the railroad tracks, and there's boxes setting around here that they were all sitting on. These guys were all very muscular and very much riders of motorcycles. And I was the only guy there that looked halfway straight, and they all sat down and immediately stared at me. And I thought, uh-oh. And all of a sudden, whoops, there's Dave back. I'll tell you the rest later.
Apologies for that, guys. I have no idea how the internet works anymore nowadays.
Oh, it's okay.
Or our infrastructure that's out there. I'm going along just great, and all of a sudden, just everything drops. So apologies. Rob, I did hear your question about the hook angle. I still agree with you primarily that you want to, when you're setting the blade height, you definitely want to keep the blade as low as you can, but set it so that your that the bottom of the gullet clears the workpiece, right? That allows the chips to get passed out of the cut site, but not so high that if you inadvertently put a body part across it, you're not going to have a catastrophic injury. So I always would tell people generally lower rather than higher in that whenever you're doing that. Okay. Anyways, where were we?
Carbide grade selection.
Okay. Can everybody see my screen?
Yes.
Fantastic. All right. So just let's go back to the blade selection guide real quick. I'm just going to leave this in the mode that it's in. So we were talking about the TCGs, and then really the last, or the modified TCGs and the modified ATBs. Again, this is really the realm of most plastics, ferrous metals, and carbon steels, and then your stainless steels. And again, only difference in those is really kind of what you're looking at for the hook angles. Again, we talked about the modified ATBs really being primarily for plastics with a 0 to -5 degree hook angle, and then the modified TCGs primarily for your carbon steels and stainless steels. Really, again, 0 to -5 on the carbon steels, and then that low hook angle on the stainless steels of about 0 degrees up to about 3 degrees. What I would suggest. Moving on to the carbide grade selection. There's two major classifying agencies out there: ANSI and then ISO. Of course, the ANSI is the American National Standards Institute. ISO is International Standards. So the C1, 2, 3, and 4 grades, C5 grades are really what you'll see in most advertising from most U.S.-based manufacturers, right? where they really kind of touting, their grade of carbide. And really, key thing to remember there is as you go down through those grades, C1 down to C5, that's a carbide that's going to have better mechanical properties, better hardness values, which increases the wear resistance of the carbide, and or other properties. It might be thermal resistance of the carbide. We really start talking about metal grades of carbide, things of that nature. And then the ISO standard is the direct opposite in terms of a large number, meaning lower grade. And then as you go to a lower number, it means a higher grade of carbide. And then when you get down to really the metal cutting grades, P or M is what you'll see for most of those, and or Cermet, which is ceramic metallic grades of metal of a cutting form now, not carbide, but ceramics, which is really the newest kinds of tooth form you'll see out there, again, for cutting metal. Several manufacturers in the last few years have come out with blades, along even with my current employer. So just going through those again, C1 really equivalent to K30 grade. It's really the lowest grade of carbide you can get now, and really primarily for wood composites. But really, for the difference in the money, I think really C2 grade of carbide, K20, K25. That's really good. It's really for softwood manufacturing. So, pines, things of that nature. Again, because it's not such a hard wood, you really don't have to worry about the blade wearing out prematurely. But as you move over into wood composites, plastics, or non-ferrous, they're again much more abrasive. The chip is generally less free to come off the toothpaste, things of that nature, so they will wear faster. Wood composites specifically have a lot of glue in them, and those glue packages can be quite abrasive and corrosive at the cutting site. So really, C2 I would really recommend for solid softwoods, grade wood along those lines. And then really C3 grades, that's sort of a K10, and they're really versatile. They're really good for wood composites, plastics, and to a certain degree for non-ferrous metals as well. Really, those are the grades you'll see for your kind of mid-level saw blades that are out there. So number of different brands exist there. Really primarily, I think, for fine woodworking, things of that nature. Generally, trim work, other things of that nature. That you'll see. Again, very because of the hardness, but the wear resistance of that carbide, good if you are cutting and you happen to hit a metallic structure, it's not going to damage the carbide generally. So really good grade, most versatile, I'd say. And then above that, C4, that's really your industrial grades of carbide that you're going to get. So your high-end woodworking saw blades generally carry those grades of carbide on them. If you've got a lot of work that you need to do this on a regular basis, I think that the little extra money going up to a full curve C4 type saw blade is really your best bet. And again, really good for wood composites and really good for non-ferrous metals as well. They'll also cut plastic, and frankly, if it's the right tooth form of TCG, they will cut ferrous metals, both carbon and stainless steel. But you will have a much reduced lifetime of the blade if you're cutting those materials. And then above that, your metal cutting grades, PM or C5, and again for carbon steel and stainless steel. And then, above that is the Cermet grades. And again, Cermets are somewhat new to the market, but I do know that the price that you pay for Cermet is coming down as it gets, more and more production in it. But definitely worth the money if you're doing a lot of metal cutting. in your work. So really, that's what I had today in terms of what what we had, what I thought you guys might be interested in. Any additional questions?
I have a few, but I'd rather open it up to the floor so some of our guests can ask before I start rambling.
Okay.
So feel free to raise your hands if you can, hit the little raise your hand button. At this point, we could probably stop the share screen too. That way we can all see each other a little easier. If somebody's got a hand up, we can see
Absolutely.
it.
Do that. Okay.
There we go. Okay, well, I don't see any hands up at the moment, so I'll go ahead and ask one of my questions. You had a pretty broad range there of options and variables and whatnot to consider. I'm curious, do all of the major manufacturers produce blades that have, some or all, of these different characteristics in the line? Are there any particular manufacturers you tend to recommend above others? I obviously know you work for a particular one, but I'm just curious.
Right.
I guess let's put it this way: what blades do you use when you go shopping for a new blade?
Yeah, that's kind of a little bit of a loaded question, Mike, just because I'm in the industry. I've got a shop full of blades that I can use. I've got a number of blades that are pre-production product that's still sitting in a box waiting for me to wear out the previous blade. Really generally, I for the type of work that we're doing, I do think that a certain number of the Freud blades are very good. They've been a consistent manufacturer for a long time. And they have the Diablo line versus their Freud industrial. So I definitely think those are very good. The DeWalt woodworking line, which no longer is in existence, was a very good product, very comparable, really high grade of carbide, really good plate. Are definitely ones. And frankly, the reason I'm with the company I'm with now is because they're really trying to improve really their industrial saw blades, and there's been quite a bit of work done before I joined the company. So the Hercules line on that side, and then really outside of that, there's a number of other manufacturers that are really U.S. centric that make a really good saw blade. My overall suggestion for most folks is if you're really trying to understand really what you're looking at, every major manufacturer has really good websites and has a lot of really good information out there about selection guides and what blade you should be picking for different applications. And they've got a lot of bright folks that work for them that are doing this. So I wouldn't really say my word is absolutely gospel, because there is differences of opinion, between myself and other individuals I know that do this work about certain of the things we talked about today. But, definitely if you have a manufacturer you're really used to using, I would definitely suggest using their resources, if you've got questions, in addition to what we've talked about today.
Thank you. Before I ask another one, does anybody else have a question they'd like to throw in there? Miles. You're on mute, Miles.
There we go. Dave, on the packaging today, what do they actually put on? How much of that information that you were talking about is actually available to us at the point of purchase?
Yeah, that's another good question, Miles. It's if the manufacturer is really interested in selling the product, they're going to list number of key things, right? They're going to list all of the key geometries we talked about today. So they're going to tell you about the hook angle. They're going to tell you about plate thickness. They're going to tell you about kerf width. They may not tell you about the ATV angle specifically that you have there, but that's definitely something you can look at and know the difference between a high ATV and what, you know, you would call a more regular ATV. They're going to list a lot of that stuff. They're also more than likely going to tell you about the grade of carbide that's on the saw. So you have a, you know, pretty good idea of, hey, if this is a C3 grade of carbide, it's going to be, you know, this level. If it's C2, it's going to be this level, that sort of thing. So that's generally on there. And then most manufacturers are going to give some details around the types of materials that the blade is really good for, you know, for using. So that's pretty commonplace.
Any other questions? All right, so I did want to ask about maintenance for blades in particular. As far as sharpening or not, do you know, are there any good, you know, methods for a, you know, home, you know, woodworker to consistently take care of their own blades? Would you always recommend taking it to a pro and having them, you know, clean the teeth up? You know, what would you recommend as far as that goes?
Right. So I think the one thing that is important that will extend the life of the blade is to make sure that you have a blade cleaning product. And there's numerous retailers that sell a product like that, but it's just really primarily there. And this is usually for wood cutting applications, blades that are cutting wood, where the swarf or the wood dust builds up on the shoulders of the blade where the radial and tangential reliefs are. And anytime you can take that blade and you can just, you know, clear that material off of the blade, that's going to extend the life of the blade pretty significantly. Again, those angles for some manufacturers are very low, so it doesn't take the blade to get that dirty before the blade will start to try to burn and things of that nature. But it usually doesn't have anything to do with the edge sharpness of the tooth form. It's really more to do with the, you know, being able to clean the blade up. So that's one thing that anybody that has, you know, saw blade can do. It's, you know, most of these products are, you know, over the counter, you know, found at multiple places. In terms of the actual blade sharpening, HFD sells a product that can sharpen blades. I don't think a lot of it. I frankly would tell you that if you want to go the sharpening route, that you find a qualified blade resharpener where you are. And generally, most blades, especially the industrials, have what's called a European tooth form on them. So they have usually are thicker front to back, so they allow the blade to be resharpened, you know, 4 or 5 times before it's, you know, at a point where, you know, the cutting edge is, you know, starting to get be a smaller diameter than the back of the shoulder, things of that nature. So yeah, and a number of the manufacturers do have programs where you can call a number and they'll identify a qualified resharpener in your area. I know that's something that we were trying to do at DeWalt through the Delta line. Never really got off the ground, but that's I definitely think you have to have quite a bit of know-how and very specialized equipment to resharpen carbide circular saw blades. So best to go to a professional in that regard. And value-wise, I think it's very good value, because if you're paying $70 or $80 or more for a certain type of circular saw blade, the cost to have a blade resharpened is usually half or less than the price of a brand new blade. And you essentially will get a blade, if the guy knows what he's doing, returned back to you that, you know, will have another lifetime on it for half the money.
Thank you. Yeah, really good answers. All right, well, we're right at the hour here, but I'll give you guys one last chance if anyone else has a question they want to get in here. All right, I guess everybody's gotten enough information for one day. Well, David, thank you very much for your time. Did you have anything else you wanted to add in there before we close up?
No, like I said, I would just suggest anybody that, you know, that is out there that has a favorite manufacturer or, you know, considering a circular saw blade, purchase. There's a lot of good information out there on the World Wide Web that you can find and gather, and but hope this was helpful for everyone that was on today. So thanks again, and everyone have a good day.
Dave, thank you very much.
Thanks for joining us. And thank you everyone else for joining us as well. In about 2 weeks, we will have another session. In that one, we're going to be hosting the Wazer water jet company. They're going to be giving us a demo of their benchtop water jet system. It's one of the smallest in the industry, but if you're looking for water jet cutting technology in a pretty small package, I've got some of the samples on my bench here at work, and they actually look really good. So if you want to see that technology at work or ask any questions of them, their representatives are going to be with us in about 2 weeks. Stay tuned for your APMM announcement emails. You will see some notifications about that coming up. So with that said, again, I'll thank you all for your time today, and I hope you all learned a lot. Have a great afternoon. Bye-bye.